Okay, so this morning class, we will be discussing the Le Chatelier's principle. This one is a principle in chemistry developed by Henry Louis Le Chatelier. So, we'll get to know this one. Step by step ito kasi medyo confusing yung kanyang principle. Okay? Now, last time we discussed, right, the chemical equilibrium. When we say chemical equilibrium, the rates of the forward and the reverse reactions are equal. So, di ba meron tayong tinatawag na reaction na pwedeng yung reactant mag-combine to form the products and the other way around. So, meron tayong double-headed na arrow. So, di ba, meron tayong reaction na ganito. So, yung going to the right, that is our forward reaction. And going to the left is our reverse reaction. We achieve chemical equilibrium if we have equal rates for both sides. Okay? Equal yung forward and reverse reaction. Now, in the principle of Le Chatelier's principle, he was concerned about a stress in a system. Okay? Kung ang tao ma-stress, yung chemical reaction natin also, class, can experience stress. And that, if the chemical reaction class experiences stress, that means equilibrium will be disturbed, and thus the equilibrium will shift in a manner to relieve or to neutralize the stress. So that is our goal for Le Chatelier's principle. Meron tayong supposedly equilibrium in our chemical reaction. However, because of the presence of that certain stress in the equilibrium, na-disturb yun. Nawala yung equilibrium. Hindi na siya equal, hindi na siya balance. So ngayon, magre-react yung ating system. Magre-react yung ating chemical reaction system. And ang reaction na yon is, ang purpose nun is to relieve, to get rid, or to neutralize the stress. Okay? So yan yung purpose talaga of the Le Chatelier's principle. So actually, ano lang ito, definition. I'm really not feeling well today. Give me a minute. Okay? Okay, sige. So we have the same definition how this one is talking about the system will shift to the direction wherein it can neutralize the stress. So ito din naman parehas lang yung kanyang sinasabi. If the chemical equilibrium is disturbed because of the presence of stress, magre-react yung system to remove the stress. So ano ba yung sinasabing stress na yan? Ito kasi yon, factors influencing equilibrium. Ito yung mga stresses na tinatawag in a chemical reaction or a chemical equilibrium. So una, we have here change in pressure. If you have a system, you have a chemical reaction taking place, and then suddenly there is a change in pressure, that change in pressure will become a stress to the system. Okay? It will disturb the chemical equilibrium. Okay? Therefore, we need to get rid or to neutralize the stress. Another one is change in temperature. So you have one chemical reacting with one chemical. So supposedly they will form a product, and then We have forward and reverse reaction there. Supposedly there is chemical equilibrium. Their rates should be equal. However, if you subject that to heating and then there's change in temperature, the chemical equilibrium will be disturbed. Okay? So later we'll see how the system will react and get rid or neutralize this stress in the form of change in temperature. And lastly is the change in concentration. Therefore, if you have chemical reaction going on, and if you change your mind, oh, I need to add concentration of this one reactant, that additional concentration class will become a stress to the system. When I say system, I am referring to the chemical reaction itself. So again, the change in concentration will become a stress. So all of these are actually influencing our equilibrium. So let's discuss them one by one. Okay, let's start with the effect of pressure change. Now, take note for pressure, most likely, pressure will only affect substances that are in their gas form. Okay? Again, in their gas form, itong pressure na ito. Si solids and liquids and other solutions will not really be affected even if there is a change in pressure, unless na lang if the pressure is extremely large. Okay? But in most cases that the pressure is not really very large class, walang mangyayari kay solid, kay liquid, and kay solution. Okay? So si gas lang talaga yung maaapektuhan ng pressure change. Okay? So, ganito yun. I don't know if you can still remember in your high school chemistry, the Boyle's law. This one is a gas law stating that the pressure is inversely proportional to the volume. So again, this is referring to the gas. Again, take note of this law. I just don't know if you can still remember this being taught to you in high school. Boyle's law states that the pressure of the gas is inversely proportional to its volume. So you have this formula. P1V1 equals P2V2. Anong ibig sabihin ng inversely proportional? Pag tumaas yung pressure class, bababa yung volume. And the other way around. What I mean by that, if bababa yung pressure, tataas naman yung volume. So ito yung sinasabi niyan. Okay? In the case of gas, the effect of pressure change is dependent upon the volume change or volume changes produced by the reaction. So they go hand in hand, pressure and volume. Pag mag-change ang volume, automatic mag-change din ang pressure. Pag mag-change si pressure, that means volume is also changed. Okay? Do you have questions so far? Pressure pa lang ito ha, isa ito sa makakaapekto sa chemical equilibrium natin. Yes, Maywin? Do you have question? You may send your question sa chat box if you cannot turn on your microphone. Okay? You ask question ha kasi baka mabilis masyado ako. Tapos nagdiretso-diretso na ko. Wala data nagkasinabot sa ato ang Boyle's law. Sa ato ang change in pressure. Yes. Anything that you would like to clarify? Wala. Take note ha, please take note. This pressure class, this change in pressure will only affect gases. Okay? So solids, liquids, and solutions will not be affected. So I am talking here about the gas. So if you have a gaseous substance in your system, if you change the pressure, the equilibrium will be disturbed for that gas. Okay? And take note of these changes also. Kasi pressure is inversely proportional to volume. So if you have increase in pressure, you will have decrease in volume and vice versa. Okay? I hope nagkasinabot ta, ana. Okay? So, eto na ngayon yung Le Chatelier's principle. Paano magre-react ang system to get rid of this stress? Okay? Paano magre-react yung system to neutralize the change in pressure? So if we are going to read what is written on the screen, ang sabi dyan, if there is an increase in pressure, take note, isulat natin. If meron daw increase in the pressure of the system, remember class, bababa yung kanyang volume. The reaction will shift in the direction, mag-shift daw ang reaction class in the direction of fewer moles of gas. Meaning, bibilangin natin ngayon sa chemical reaction which side has fewer moles of gas. Kasi dyan pupunta yung direction of the chemical reaction. So, di ba, if meron tayong chemical formula like this is a liquid, this is solid, pero in the product may nabuo ka na gas, ito liquid pa rin ito. So kapag ka nag-change ang pressure daw nito class, remember this is the backward reaction, this is the forward reaction. So supposedly they have the same rate kasi they have chemical equilibrium. But again, if you change the pressure, there is change in pressure, the volume of this gas will decrease. And saan daw mag-shift yung reaction doon sa side na merong fewer moles of gas. So how do you know the moles of gas? Yung coefficient niya dyan. Okay, titingnan natin yung coefficient, yung number sa tabi ng chemical formula. Okay, so ito meron siyang isa. So this side has 1 mole of gas. Ito naman wala kasi liquid and solid yan siya. So ano daw ang ibig sabihin? Magfe-favor yung reaction doon sa side na merong, fewer moles of gas. So definitely ito kasi wala nga siya. So meaning, mag-shift yung direction of the chemical reaction going backward. Okay? Or going to the left. Or again, going backward. Okay? To neutralize the stress class. That's how the chemical reaction neutralize the change in pressure. So instead na equal na sila because of the change in pressure, magfe-favor ngayon. Most likely ang magiging direction ng reaction is going backwards, which means more of the products will react with each other to form the original reactants. Okay? So yan yun siya ang gagawin ng system kapag magkakaroon ng change ng pressure. So let us again discuss the rules. I-summarize natin siya para mas mabilis niyo siyang matandaan and maintindihan. So starting with, again, if there is a change in pressure, automatic that also means a change in the volume. Saan daw mag-shift yung direction of the reaction? To the side wherein there is lesser number of gas molecules or moles of gas molecules. Okay? So parehas lang yan siya ha, gas molecules or moles of gas. Yung isa naman, baliktad. Paano kung binawasan natin yung pressure? So pag binawasan natin ang pressure class, that means ang volume ng gas ay tataas. There will be increase in the volume. So where is now the shift in the direction of the reaction? It will shift to the side wherein there is more number of gas molecules. Okay? Or merong mas maraming moles of gas. Okay? So in studying class, you may have this one, yung summary natin para mas mabilis niyo siyang matandaan. Okay? Sige, do you have questions before tayo mag-move on? Wala. Turn na good. Sige. So, let's have the example. This one is our example. Sige. So, we have this reaction. Sulfur dioxide, which is a gas, reacting with 1/2 mole of oxygen, which is also a gas, and it yields sulfur dioxide, which is also a gas. Okay? Gas pa rin ito. Example. For example, given na ito yung chemical reaction and this is already in equilibrium, paano daw pag ma-disturb natin ang system? If the pressure is increased, what will happen daw if ang pressure dito mag-i-increase? Before ka sumagot dito, class, you have to identify first how many moles of gas do we have. On the reactant na side, bibilangin mo siya based on the coefficient. Okay? So kung walang coefficient, class, that is automatically 1 ha. So in this side, 1 plus 1/2, you have a total of 1.5 moles or molecules of gas here. On the product na side, okay, walang coefficient dyan, that's automatically 1 molecule or 1 moles. So ano nga yung rule natin? If the pressure class is increased, yes, if the pressure is increased, mag-decrease yung volume. Saan daw mag-shift yung ating equilibrium ng system?
Sa may lesser na molecules, ma'am.
Okay, lesser moles or molecules ng gas. Okay? So, saan yun siya? Dito na side. Kasi 1 molecule lang siya on the product na side. So, how do we answer this? Actually, the question is, where is the shift on the reaction? So, you may answer to the right. To the right kasi going there. Ako ha, this is the right side here. Okay? So if the pressure is increased, equilibrium or the direction of the chemical reaction will be shifting to the right. Okay? Or you can answer forward. Okay? Meaning mas marami, class, yung magre-react na reactant and maraming ganito yung mabubuo in the system. That's how it will get rid of the increase in pressure. Okay? So how about if the volume is increased? Ano sabi ko kanina? Pag mag-increase ang volume, what will happen to the pressure?
Baba.
Bababa.
Magbaba po, ma'am.
Mag-decrease po.
Okay, very good. Mag-decrease si pressure. So ano yung rule natin for this? Saan yung ating shift of the equilibrium? Doon sa more
Or
May
number.
greater number po.
Sa reactants, ma'am.
okay, moles or molecules ng gas. So saan yon? Dito sa reactant. So our answer here is pabalik to the left. The direction will favor the backward reaction. That means more product will decompose to produce this one. So sa system, mas maraming ganito, silang dalawa. Just to get rid of the change in the volume. Okay? So yan lang. I hope hindi ma-confuse ha. Kasi yung sagot lang dyan, either to the right or to the left, or forward or backward. That is again an attempt of the system to get rid of the stress. So this time it's for the pressure. Okay, let's have our participation. And you answer this. So example number 2, you may send your answers on the chat box. You have here a carbon which is solid reacting with water in its gas form, and then it will yield carbon monoxide plus hydrogen. Okay? So ito yung chemical reaction natin. So question number 1, if the volume is decreased, where is the shift in the direction of the chemical equation or the chemical reaction? Saan yung i-favor niya? To the right or to the left? Let's just have to the right or to the left para mas madali. To the right is syempre going there ha, to the right. Going there to the right, and then going backwards is to the left. Okay? Sige, kayo muna. Let's see kung naintindihan yung sinasabi ko kanina. Neutral? Oh, sorry. Hindi ko pala siya nalagyan, no? This one is also a gas. Hindi pala nalagyan kung ano yung state of matter for hydrogen. Hydrogen is a gas. So definitely that is counted. Okay? Sige. What is the condition here? The volume is decreased. So let's count the number of moles. This is not counted since that is solid. So this is counted here. You only have 1 mole or 1 molecule here. On the other side, this is a gas. So that's 1. And this is also a gas. So you have 2 moles here on the product na side. Now what happened here? The volume is decreased. The pressure will increase. This will favor lesser moles of gas. Moles or molecules, parehas lang yan ha. So saan yung lesser dyan? This side. So basically, the chemical reaction will be backwards. More product will react to form the original reactant. So the answer here is to the left. So definitely ito, parehas lang naman no, if the pressure is increased. Kasi if yung volume mag-decrease, si pressure tataas. The shift will still be on the lesser moles or molecules of gas, and this is still going to the left. Okay, naintindihan? Do you have questions or clarifications? Baka may gusto kayo i-clarify. Wala. Sure na. Sure na yun. So, this is not included in the quiz tomorrow. We will just have the chapter 1, the chemical kinetics. Yes, Atasha. Okay, sige, let's add another reaction. Wait lang. Ulat pa na lang ha. Let's look for a chemical reaction with gases. So you have here zinc plus sulfuric acid yielding zinc sulfate plus hydrogen. Okay, so this is our chemical equation. So what will happen if the volume is decreased? And what will happen if the pressure is decreased also? We'll just have to identify. So number 1, let's answer number 1. Where is the shift of the equilibrium of this chemical reaction if in case the volume is decreased? To the right or to the left? Or is it backward or forward?
To the left, ma'am.
Okay, sige. So remember class, on this side, wala tayong gaseous molecule. So 0 talaga yan. This is a solid, this is a liquid. But on this side, you have 1 mole of gas. So ito, volume is decreased. The volume is decreased, the pressure will be increased here. The shift will be on the fewer moles of gas. So, syempre, this is the side with fewer number moles of gas. Actually, wala nga siyang gas. So, automatic the shift will be to the left. Okay, the reaction will favor the backward reaction. Kaya, to the left siya. To get rid of the decrease in the volume. So, if the pressure naman is decreased, what will happen? Ano mangyayari if the pressure is decreased? So, pag magtaas si pressure, ano daw yun? Bababa si volume. Sinasama ko talaga silang dalawa para hindi niyo talaga makalimutan yan. We call this the Boyle's law. Okay? Where is the shift? Ay, baliktad pala. Decrease pala ito, sorry. Ulit. If the pressure is decreased, and then the volume will increase, baliktad naman ito. This will favor the side with more number or more moles of gas. So definitely ito yung side na mas marami ang gas. So to the right siya. The chemical reaction will favor the forward reaction. So definitely more reactants, syempre, will react to form the products. Okay, ito yung i-favor niya na side. ng chemical reaction. Naintindihan ba yan? Or na-confused pa rin? Wala na? Sure na tayo with that. Wait lang. Kasi for example, let's look for hanap tayo ng maraming gas. Okay? Okay, so for example, this one, if the pressure is increased, what will happen? And if the volume is increased, what will happen to the direction of the chemical reaction? You have 4 aluminum plus 3 oxygen yielding 2 moles of aluminum oxide. May kulang ata tayong quiz sa laboratory, no? Hindi ko katandaan. Hindi ata tayo nakapag-quiz ng activity number 3. We need to have that pala, yung naming. I'll give you a short quiz tomorrow, maybe 10 points lang sa naming, just for the naming. Kalimutan ko. I need to have 3 quizzes. Sige. Again, if the pressure is increased, class, sabi dyan, if ang pressure mag-increase, si volume mag-decrease, this is on the fewer moles of gas. So, ilang gas ba ito? You have 3 moles here on this side. This is solid, this is gas. Remember, may 3 siya dyan na coefficient. On this side, this is purely solid, so wala tayo here. So, fewer man tayo, class, dito sa increase in pressure. Therefore, this will favor the forward reaction. So, the shift will be going to the right. Okay? So, how about if the volume is increased? Baliktad ito. Pag mag-increase ang volume, bababa si pressure, the shift will be on the greater or on the side with more number or moles of gas. So, ano ito? Baliktad. Okay. Going to the left. So, the reaction will be shifting backwards. Okay? It's favoring the backward reaction. Okay. So, that's for the pressure. Can we move on now? Let's have the second cause of stress in a system. Okay, let's complete them. The second one is the effect of temperature change. Okay, so again, temperature class ha, a change in temperature is a cause of stress in a system. So equilibrium will also be disturbed. Okay, So according sa Van Hoff's law, which is actually a special application of our Le Chatelier's principle, yung shifting daw of the equilibrium pag merong change in the temperature is yung direction ng shift is going to the opposite side wherein hindi mo makikita yung heat na yan or yung temperature na yan. Ano ba yung sinasabi ko? Kasi kapag may chemical reaction ka na like this, hahanapin mo saan yung heat. Yung triangle na yan, that is class A symbol for heat or for energy. Okay? Again, this is a symbol for heat or energy. Pag nakakita kayo ng chemical equation na biglang may triangle o kaya kung hindi triangle ang nakalagay is letter E, that means energy or heat. So ito yung mga chemical reactions class na tinatawag nating either exothermic or endothermic. Anong ibig sabihin yan? Si exothermic, this one involves the release of heat or energy. I don't know if you have encountered this one in the laboratory. May mga reaction tayo class na pag pinaghalo natin yung substance A and substance B, yung product class is biglang mainit siya kahit hindi mo naman siya binoil, hindi mo siya hinit over a Bunsen burner or a hot plate. Mainit lang talaga siya after the combination of the two or more reactants. Yan yung tinatawag natin na exothermic reaction. So included in the chemical equation yung heat na yan or yung energy. Si endothermic naman, this one absorbs heat. So kapag endothermic yung reaction class, si heat hindi mo makikita sa product. Dito mo siya makikita sa reactant. Wait lang. Ayaw. Ayan, dito mo siya makikita sa reactant. Again, for endothermic reaction. Kasi mag-a-absorb siya ng heat. Okay? Magre-release ng heat dito sa kabila. That's exothermic reaction. And kapag endothermic, nasa product yung heat. Okay? So, i-summarize natin ang rule ng Le Chatelier's principle sa temperature change. If mag-increase ang temperature class, the shift will be on the opposite side of the heat or the energy. So going on the side na walang heat or walang energy. Pero pag bumaba yung temperature, the shift will be favoring the side wherein you can see the heat or the energy. So I hope that is clear. Summarize natin para madali siyang maintindihan. This is according to the Van Hoff's law. Again, that law is just a special application of our Le Chatelier's principle. Okay, so let's take this for example. We have here the formula. You have a nitrogen gas plus 3 moles of hydrogen. This is also a gas, yielding ammonia. NH3 is ammonia, which is also a gas. And take note that this is an exothermic reaction. So heat or energy is being released, okay, as one of the products. So if this equilibrium is disturbed because there is an increase in temperature, where do you think will the direction of the reaction will shift? Saan papunta? Saan yung i-favor niya na reaction? Kulang yung arrow ko. This is class? irreversible reaction. So, increase daw. Ano nga sabi? Pag mag-increase ang temperature, opposite ng side where you can see the heat or the energy. So, this one, itong side na ito, dito natin makikita yung product. Sa product, I mean yung heat or yung energy. So, the shift will be going backward. So, the answer here is to the left. Okay, very good. This is going to the left. Okay? Or you can answer backward reaction. So it will favor the backward reaction, which means ammonia will decompose to form nitrogen and hydrogen. Now, how about if the temperature is decreased? Yung i-favor niya is yung side where you can see the heat or the temperature. So it's going here. So let's answer to the right. Okay? Or it will favor the forward reaction. Okay? Do you have questions about this one? Pwede niyo siyang isulat in your notebook or your index cards, though you are not allowed to bring your index cards sa quizzes and sa exam nito kasi you really need to know this by heart. Or just for you to easily memorize this. I-summarize niyo siya in a paper. Okay? Sige. Okay, so how about this one? Sige daw, kayo daw kung tingnan natin kung naintindihan talaga. You have here the reaction nitrogen plus oxygen yielding 2 moles of nitrogen monoxide. And may nakalagay sa baba, an endothermic reaction. Sige. Sabi ko kanina pag endothermic reaction,
Absorbs heat.
okay, absorbs heat. So where do we see heat? Sa product or sa reactant?
Reactant po.
Okay, the reactant. Sige, you answered the first question. What will happen if temperature is increased?
Forward.
Forward. Sige. So since this is an endothermic reaction, heat is located here in the product. So if there is temperature increase, meaning it's on the opposite side of the heat. So tama yan siya na the direction of the reaction will shift to the right. It will favor the forward reaction instead of the backward reaction. So that means more of these reactants will react to form more of this compound. So in a system class, mas marami kang makita na nitrogen monoxide than yung hiwalay na ganito. Okay? So meaning yan, magsi-speed up yung reaction. Kasi it is trying to get rid of the change in the temperature. So kung bababa yung temperature, what will happen? Saan papunta yung shift ng system? Yeah, hindi not all the time not all the time nilalagay yung heat or energy sa chemical equation. So minsan ilalagay lang whether it is endothermic or exothermic reaction. So you should know also ano ibig sabihin ng endo and exothermic reactions. Okay, so where is our shift here? Our shift
Sa left po.
the left. Okay, very good. This is to the left. Kasi bababa ang temperature, babalik yung reaction. It will favor the backward reaction kasi nandoon yung heat since this is an endothermic reaction. Questions? Or clarifications about this? Wala? So let us move on. Sige. So this is our last last stress, effect of concentration change. Okay? So itong masyadong marami yung nakasulat sa screen, hindi ko yan gusto. Hindi ko gusto daghan kay words. Pag sinabing effect of concentration change, class, it means ganito. Para siyang siso. Diba pag nagsiso ka dyan, yung chemical equation daw parang siso. Ganito siya. So supposedly, balance yan, diba? Balance ito sa siso. Ang chemical reaction, balance. Sa concentration change, dili lang straight ako, pero balance na siya. Pag magkakaroon ng concentration change class, ganito yung mangyayari. Example, nagdagdag ka dito. Nagdagdag ka dito ng concentration. Yung reactant, dadagdagan mo ng concentration. Di ba kung mas bugat din na side, what happened to the siso? Magiging ganyan siya. Okay? Again, pag bibigat dyan sa product na side, the siso will look like this. Ang shifting of the reaction class is on the opposite side. Okay? Kasi ino-neutralize, ibabalik natin siya sa equilibrium. So if this is the right side, this is the left side of the chemical reaction, mabigat yung right side kasi nagdagdag ka ng concentration. So definitely yung shift of the reaction will be going to the left. Okay? Going to the left siya, going there. Kasi we need again to neutralize the system para bumalik siya like this. Okay? Or if the other way around, dito na side ka nagdagdag ng concentration. So what will happen to our siso? Magiging ganyan naman siya. Okay? Mas mabigat na ang nandito na side sa left side of the chemical equation. So, yung shift nito to get rid of the change is the system is pabalik. Okay? So, to the right naman. Ay, nabaliktad. Baliktad. Yan naman na. Ulit. This is the left side. This is the right side. This one is the left and this is the right. Ano man to? So ito siya class. This should be going to the left side to get rid of the system. Kasi nga mas mabigat dito kasi nagdagdag tayo ng concentration sa product na side. So the reaction will favor on the backward reaction. Para again, mabalik siya as balanced. Okay? So, kung na-confuse kayo with the concentration class, pwede kayo mag-draw ng siso para mas madali sa inyo. Okay? Now, for the concentration, both gas, solution, or even the solids are affected here sa change in concentration. Yung pressure lang talaga ang iba kasi gas lang talaga ang maapektuhan nun. Pero this time, maapektuhan lahat. So let's have an example. Medyo marami ito, no? This is our reaction. We have dinitrogen tetroxide. Magde-decompose siya yielding 2 moles of nitrogen dioxide. So parang siso lang yan siya, class. Okay? Mag-draw ka ng siso dyan. Meron kang N2O4 here. Meron kang NO2 dito. So, ang first scenario, pag magdagdag ka daw ng concentration dito na side sa N2O4. So, pag mas marami na siya, what will happen? Magiging ganyan siya. Kasi mas marami na yung nandito. This is the left side, this is the right side. So, where is the shift in the equilibrium here? Kapag ka mas mabigat na yung left side, saan papunta ang shift ng ating equilibrium? Siyempre, to the right. Okay? So, in our board exam, sa time ko ha nung nag-board exam ako, I can also remember drawing a seesaw in my questionnaire. Kasi yung questionnaire pwede mong sulatan. Just like in your exam, di ba, sa prelim. Pwedeng sulatan yung questionnaire. Pero yung Scantron paper, hindi mo pwedeng basta-bastang sulatan ng kahit ano. Talagang mag-shade ka lang doon. Again, when I took the board exam, nag-drawing dyan ko aning siso. Okay, para ma-picture out lang yun na ako what happened to the chemical reaction. And it will be easy for me to know where is the shift in the equilibrium. So this is to the right. Pag marami na masyado yung N2O4 natin, bibilis yung reaction na going forward. Okay? Bibilis yung reaction yan. In an attempt to get rid of the stress. Okay? The addition of N2O4 is a stress. Now, what happened now if we add NO2? Ito naman yung dagdagan natin. Ano mangyayari sa season natin? Pag mas bugatin ang side, ang season mahimog ing ani na. So, mas bugat na ang NO2 kesa sa N2O4. So, again, this is the left side, this is the right side. Where is the shift? If we add NO2,
Left.
this is going to the left. Okay, very good. Now, in some cases, class, merong like binabawasan. Okay? So, example, nagbawas ka ng N2O4. Anong ibig sabihin pag nagbawas ka ng N2O4? Sana yung side na mabigat? Kung sa siso pa na, i-picture out natin siya using the siso. Again, nagbawas ka ng N2O4. Binawasan mo yan. So, yung siso mo, magiging ganito pa rin. Kuha, mas mabigat na dito. Mas mabigat ang dito na side ha, kasi nga, binawasan natin yung N2O4. So, in this case, since parehas sila ng drawing class, the shift will still be on the left side. Okay? Now, how about removing NO2? Ito na naman yung binawasan natin. Ano mangyayari? Siyempre, mas mabigat ito na side. So, parehas sila class ng drawing neto. Mas mabigat na ngayon si N2O4 kesa kay NO2 kasi nga nagbawas ng NO2. So, the reaction here, parehas sila going to the right. Okay? Going to the right yung ating reaction for this. That's how you determine the shift in the reaction if there is a change in concentration. Okay? Oh, for me, that's the easiest way. I don't know if ano siya class. That is still the easiest way for you. Let's have another example. Yung kayo naman. I need enough space for this. Let's check. We need good chemical reactions. Okay, so number 1. Okay, let's start with this one. Kayo muna. Addition of HCl. We have here the reaction on the screen. Sodium sulfide plus 2 moles of hydrochloric acid yielding 2 moles of sodium chloride plus hydrogen sulfide. Hindi siya magbe-base sa subscript, hindi din siya magbe-base sa coefficient. The subscript is this one ha, yung maliit na number, that's the subscript. Please take note class, the subscript, again, the subscript class refers to the number of atom of elements. While itong 2, example yung number 2 dyan sa tabi ng chemical formula, ang tawag dyan coefficient. Okay? It represents the number of molecules of compounds or yung molecules mismo ng substance in a chemical equation. Sige, let's start. Addition of hydrochloric acid. Where is the shift? To the right or to the left? Wala to, dyan ako na yung answer. Bisig natulog na magbalik din ha.
Right, ma'am.
Let's see. Okay, so this one is our, ay, tingnan mo, dili man yun na siya straight. Wait, that was straight kay equilibrium man. Okay. So this is our equilibrium here. Dalawang reactant ito ha. So sabay sila dito, class. Sabayan sila dito, dalawa. And sabay din silang dalawa dito. Okay. Now, what is our problem here? Addition of HCl. Nagdagdag ka ng HCl dito. So most likely bibigat ang side na ito. This will be our drawing. Again, bibigat ang side na ito because of the addition of HCl. This is left, this is right. So yes, tama yung answer ninyo that the shift will be to the right. Okay? Sige. Now, how about addition of NaCl? Addition of NaCl, dito na naman tayo magdagdag. Dadagdagan natin dito na side. So, our seesaw will look like this kasi mabigat yung side na ito. So, let's see your answers. Okay, tama. The reaction will shift to the left. Okay? Sige. Tama yan siya. Now, how about if we remove hydrogen sulfide? This one, removal of hydrogen sulfide. Punan mo daw ito. Hydrogen sulfide dito. Pag punan mo siya, meaning gagaan siya. So, yung side na mas mabigat is this side here, Na2S plus HCl. So, your seesaw will look like this. Mas bibigat dito kasi nga nabawasan dito na side. So, where is the shift of the reaction? Going to the right. Okay, that's going to the right. And lastly, if dito ka naman nag-remove sodium sulfide naman, okay, binawasan natin ng Na2S. So, meaning gagaan dito na side, mas mabigat na yung product. So, ganito naman yung kanyang illustration. So, binawasan dito, mas mabigat na ang dito na side. So, the shift will be favoring the backward reaction. So, yes, tama yan siya na to the left. Okay? Do you have questions or clarification? Clarifications about this? Wala. Gusto nga butaan na ha. The best way to, for me ha, the best way to really answer this one for the change of concentration is to draw. You illustrate which side is heavier because of the addition of concentration, and the reaction will shift on the opposite side na. Okay, either to the right or to the left. So silang tatlo class yung tinatawag natin na na factors na mag-i-influence sa chemical equilibrium. So they will be like stresses in the system. They will disturb the chemical equilibrium. So that the system will try to get rid of them. So that's how you get rid of the stress in the system. So okay, yung kabuuang concept na yan, we call that Le Chatelier's principle. Okay? So, how about the effect of catalyst? Ano nga ibig sabihin ng catalyst? Who can still remember the meaning of a catalyst?
To send the reaction.
Okay. Is there any substance that speed up or hasten the velocity or the rate of chemical reaction? Hindi yan siya mako-consume, hindi siya kasali sa reactant. Ilalagay mo lang talaga siya, idadagdag mo siya to speed up the rate of chemical reaction. But please take note that a catalyst cannot disturb the chemical equilibrium. So it is not class A factor na mag-i-influence ng equilibrium. So kapag ka nagdagdag ka ng catalyst, walang shifting of the reaction. Wala tayong to the right or to the left. Walang shifting in the direction of the chemical equation. So kasi yung role ng catalyst is just to speed up the rate of the chemical reaction, pero both kasi yun siya. Both sides, forward and reverse reactions, will speed up in the presence of a catalyst. So again, there is no really a disturbance in the chemical equilibrium. So walang shifting na mangyayari. Okay? So I hope that is clear ha, hindi kasali si catalyst. So pag tinanong kayo, if there is an addition of catalyst, what will happen to the system? You just answer no change. Okay? No shift or no change. Hindi makaka-apekto si catalyst. Now, where do we apply the law of chemical equilibrium? Okay, so saan natin ina-apply? Bakit kailangan natin pag-aralan sila? Chatelier's principle, si chemical equilibrium. Class, meron tayong two general type of ionic equilibria in which the law of the chemical equilibrium is being applied. So number one, ionization of the weak electrolytes. Remember, electrolytes are very important in our body. Aside from they are being used in the laboratory for a lot of experimental procedures, in our body itself, we need electrolytes. The strong ones or the weak ones, we need them in our body. And we need to achieve equilibria or equilibrium of these electrolytes inside. So that's the number one application of the law of chemical equilibrium. And the equilibrium of relatively insoluble substances with their ions. Okay? We have substances in the laboratory that are actually insoluble in water. But for example, kailangan talaga nating ma-achieve yung equilibrium ng system, no? Bubuo sila ng ions. Remember, ions are positive charged. Ions are charged atoms. So, kailangan natin malaman when nila ma-achieve yung equilibrium. Both their ions na counterpart and yung substance mismo, again, which is insoluble most of the time in water. Okay? Let's talk about the types of ionic equilibria class. Again, two types of ionic equilibria. We have the so-called homogeneous equilibria. All you need to take note is this one, the word homogeneous. Remember, homo means one, and therefore, if we're going to look at the chemical equation, all of the substances there exist in this same phase. So we have here an example. Hydrogen plus iodine yielding 2 moles of hydroiodic acid or hydrogen iodide. It's the same thing. Now let's look at all of their phases. All of them class are gases. From the reactants to the product, they have the same phase. So this is what we call homogeneous equilibria. Now, if in a chemical reaction, 2 or more phases or the substances involved exist in different phases, that's the time we call it heterogeneous equilibria. Okay, so we have an example here, calcium carbonate decomposing, yielding calcium oxide plus carbon dioxide. So you have here a gas for the calcium carbonate, and then si calcium oxide naman ay solid, and then si carbon dioxide is a gas. So they exist in different phases. The two are gases, while the other one is a solid. So again, we call this heterogeneous equilibria. Okay? Questions? Do you have questions or clarifications? Wala. Sige. So, let's talk about ionization of weak electrolytes. Again, ionization of weak electrolytes class. Let's talk about electrolytes first. Kasi we are actually encountering them, no? Maraming beses na ma-encounter natin sila. Yung mga na-experience mag-diarrhea, pinapainom ng electrolyte drinks, o kaya nagre-replenish ng electrolyte to prevent electrolyte imbalance. Okay, so ano ba talaga ang ibig sabihin ng electrolyte? When you say electrolyte, these are substances that give ions when dissolved in water. Okay, so again, ito yung mga substances natin, class, mga chemical substances natin na pag nilagay natin sila sa water, dinisolve natin sila sa water, they will give us ions. Ano ibig sabihin ng ions? Charged atoms. Okay, very good. So magkakaroon ng charges, substances with charges doon sa solution natin, sa water solution natin. Now, ano yung mga examples of our electrolytes? Our acids, bases, and even salts are examples of electrolytes. Si acid, pag hinalo mo sa tubig, class, will give you ions. That is also true for bases. And most especially the salts. Pag nilagay natin yung salt sa water, talagang magbibigay yan siya ng ions. So all of them are considered electrolytes. Okay? So, wait lang ha. Bigyan ko kayo ng example. So, example nito, si sodium chloride. Pag nilagay mo yan siya sa tubig, dinisolve mo siya sa tubig, it will give you sodium ion and chloride ion. So, ito yung ibig sabihin ng electrolyte. Okay? Walang reaction between sodium chloride and water. Water is just used as a solvent, as a dissolving medium. Okay? So, sodium plus chloride ions. So, definitely, sodium chloride, which is an example of a salt, is an electrolyte. That is also true for acids like hydrochloric acids. If you place this in water, this will give you the hydrogen ion plus the chloride ion. So again, talagang magbibigay sila ng ions when they are dissolved in water. For base, you have sodium hydroxide. You mix it with water, it will give you sodium ion. And take note, you have a polyatomic ion here in the form of hydroxide. Okay? So lahat yan sila kapag nagbigay sila ng ions when dissolved in water, electrolyte ang tawag natin. Okay? Yes, water is our universal solvent. Okay, now, if you hear the term aqueous solutions, pag aqueous gani class, automatic, you should think about water. Meaning water is used as the dissolving medium. Or to simplify it, water is used as the solvent. Okay? So pag si sodium chloride dinisolve mo sa water, you will have a salt solution, but we can classify it as aqueous solution. So lahat ng solutions na water ang solvent, again, we call it aqueous solution. Okay? So for electrolytes class, water yung pinaka-importante natin na solvent. So most of our electrolyte solutions, water talaga ang dissolving medium. Pero yung pag-dissolve natin ng electrolyte, hindi lang naman siya limited to water. Meron din tayong tinatawag na non-aqueous solvents. So anong example ng non-aqueous solvents na meron ding ability to dissolve electrolytes? So we have here ethanol or our ethyl alcohol. Pwede din yung mag-dissolve ng electrolyte. The ammonia and even the acetic acid. Again, we call them non-aqueous solvents. They still have the ability to dissolve electrolytes. Now, let us classify our electrolytes. We have strong electrolytes and weak electrolytes. Pag sinabing strong electrolytes class, they completely ionize when dissolved in water and walang maiiwan na neutral molecules. When you say neutral, walang charge. So kagaya ng sodium chloride, wala ito siyang charge. So it's a neutral molecule. But pag si sodium chloride nilagay mo sa water class, lahat yan magiging ion. Si sodium, si chloride, magiging ions yan lahat. So again, if there is complete ionization, the electrolyte is classified as strong electrolyte. Okay, I hope that is clear. Now, pag weak electrolyte naman, ito yung mga substances natin na pag nilagay natin sa water, dinisolve natin sa water, hindi siya completely mag-ionize. Again, hindi siya completely mag-ionize. Merong mga particles or merong mga molecules na magiging uncharged pa rin and merong presence of the ions. So let us give an example. This one is the chemical formula of acetic acid. Remember, acetic acid is the acid found in our vinegar. Pag nilagay mo ito sa water class, si acetic acid, this will give us this ion plus this ion. Okay? So, hindi yan siya completely ionized in water. Hindi kagaya ng sodium chloride no, na lahat talaga ng components are being ionized. You have sodium, you have chloride, walang matitira na neutral molecule. Sa pagdating kay acetic acid, it will give you the acetate ion. This is an acetate ion. And this one is, syempre, hydrogen ion. Pero kasi hindi lahat ng molecules nito mag-dissociate or mag-ionize. Merong matitirang neutral ions for this. And ito yung, neutral ions, neutral molecules. Ito lang yung mga ions na makuform. Okay? So, partial lang yung ionization niya. Okay? We call that ionization or dissociation. Ionization class is the formation of ions. That's the same thing with the dissociation. Pag ang substance class nag-dissociate, magpo-form siya ng ion. Okay? So acetic acid is considered a weak electrolyte. Hindi lahat ng acetic acid class mag-dissociate and mag-form ng ions na ito. Acetate and hydrogen ions. Now, why is it again important for us to study electrolytes? Because our body itself class are made up of electrolytes. We need electrolytes to function well. Our cells, our tissues, our organs need electrolytes to function. So saan natin siya makikita? Makikita natin itong electrolytes in our body fluids. So both cations and anions. Ano nga yung cations? Positively charged or negatively charged?
Positively.
Positively charged.
Positively charged. So these are examples of ions or electrolytes that we can see in our body fluids. For cations, we have calcium, potassium, sodium, magnesium, and the list goes on. And then for our negatively charged ions or our anions in the body, we have the following examples: chlorides, carbonates, amino acetates, phosphates, and iodides. Okay? So, important yan sila sa ating body. Example, yung calcium. Calcium is needed for muscular contraction. Okay? Without calcium class, hindi magko-contract yung mga muscles natin. Now, remember, our heart is also a muscle. Again, our heart is also considered as a muscle. Therefore, pag wala tayong calcium, how can the heart contract? Okay? Pero that is also correct, Aaron. Calcium is also needed for bone and even teeth formation. Actually, our bones and teeth are made up of 99% calcium. Paano kung nawala yan sa body natin? Okay? Potassium, sodium, and magnesium are also required for processes in the body like pagbeat ng heart, yung action potential natin sa brain para mag-function yung brain natin, kailangan ng mga ions na yan. So without them, wala ding life. Okay? Hindi magfa-function yung ating cells and tissues in the body. Okay? Isa-isahin natin yan. This is chapter 2. Chapter 2. Pag mag-chapter 3 na tayo, class, iisa-isahin na natin lahat ng elements in the periodic table. So we'll have a separate discussion for this. Okay? Let's concentrate first sa study of electrolytes before natin isa-isahin yung mga elements na yan. Now, class, I have mentioned a while ago that acids and bases are also considered electrolytes. So meron tayong 3 theories for our acids and bases. Itong theories na ito will help us determine whether a substance is an acid or a base. Okay? So the first one is the Arrhenius theory. This is the water-ion theory of acids and bases. Sulat ko siya. Again, si Arrhenius theory is the water-ion theory of acids and bases. That's Arrhenius theory. Bakit water-ion theory? Kasi ito yung pinaka-common natin na definition sa acid and sa base. Sabi ni Arrhenius, pag merong hydrogen ion, automatic acid yon. Pero pag merong OH or hydroxide, automatic base daw yon. That's Arrhenius theory. Kaya tinawag siyang water ion theory. Water ion kasi pag i-combine mo ito class, HOH, you will have the water. H2O. Okay? Now, the problem is not all acids and bases contain hydrogen and hydroxide. Kaya meron pa tayong additional theories. The first one is the Bronsted-Lowry. Para madali nyo siyang maintindahan ay matandaan class, Bronsted for proton. Okay? Sounds alike. Well, hindi talaga totally, but nevertheless, sounds alike. H3O plus, I'll discuss to you what is that. H plus is hydrogen ion and H3O plus is called the hydronium ion. We'll have a separate discussion of this. Okay. Again, H plus is hydrogen ion. H3O plus is hydronium ion. That is formed if water molecule reacts with another water molecule. But nevertheless, if merong either hydrogen or hydronium ion, that is considered an acid. Okay? So again, going back to the Bronsted-Lowry theory, Bronsted for proton. But you have to take note that the proton donor is an acid. So proton, di ba, positively charged subatomic particle. Pag proton acceptor, base yun siya. Now, hindi din kasi lahat ng acid and bases makikita natin na nag-donate or nag-accept ng proton. Kaya, Lewis theory is also formulated. So this time naman, Lewis letter E, this is for the electron. Pero baliktad ito sila sa proton ha. Kasi si acid proton donor, pero electron pair acceptor siya. Si base, proton acceptor, pero electron pair donor naman. Okay? So this is how you study all of our theories sa acid and bases. I-ano na lang natin siya, i-table para mas madali. Okay? So it's already 9:28. I will continue my discussion about acids and bases. Next meeting, we will be discussing weak acids, how it dissociates. Again, when you say dissociation, it means nag-breakdown siya to form ions. Okay, that includes also weak bases, and then application natin sa drugs nitong study of electrolytes. And then we will talk about water, our universal solvent, and magkakaroon ito ng computation. Okay, ayan, may calculation ito. And then after that, since we are talking about acids and bases, we will also talk about pH next meeting. pH and pOH. Okay? And syempre, meron din itong calculations. Marami itong calculations actually. And then lastly, we will talk about buffers and buffer solutions. Okay? May important ito lahat sa study of chemistry and drug discovery. So yun yung i-discuss natin next meeting.